bursts of light erupting with the force of billions of hydrogen bombs. They move at hundreds of miles a second. Then, after minutes or hours, they fade away. The dark areas across the solar disk are coronal holes, which may provide new clues to the sun's interior, and may be a source of a solar wind that blows outward to the farthest planets. On Earth, effects of these solar events are visible when auroras light up the dark Arctic sky and radio communication is disrupted. The Sun is an average, middle-aged star. Yet it will generate heat and light for billions of years to come, as it has for 5 billion years past. It dominates the motions of all bodies in the solar system. Nearest the Sun and obscured by its intense glare is Mercury, a cratered planet much like our Moon. Temperatures rise to 800 degrees, but no clouds or atmosphere protect its ancient surface from the searing heat. Moving outward from Mercury, we encounter Venus. Its perpetual cloud cover traps the radiant energy of the Sun within an atmosphere of incredible pressures. On the surface, only a reddish glow reveals the presence of the Sun. Beyond Venus, 93 million miles from the Sun, is Earth. Its great oceans forming the clouds and air currents which warm and irrigate the planet, shape its continents, and nourish life. Its satellite, the Moon, airless, waterless, and scarred by meteors that have bombarded it since the time of its formation, now bears the imprints of our astronauts. Probe of the planet Mars has discovered a dynamic and evolving planet with unexpected geological features. A volcanic mountain, many times larger than the largest volcano on Earth. A vast and deep canyon, extending for 2,500 miles. And dry, river-like channels that may have been carved by running water. Beyond the orbit of Mars is the belt of asteroids, craggy chunks of rock and metal, some as small as boulders, others hundreds of miles in diameter. About 500 million miles from the Sun, we encounter the first of the giant gas planets, Jupiter, the colossus of the solar system, more massive than all the other planets combined. Deep beneath the maelstrom of clouds that band its surface is a primordial atmosphere much like that in which life awakened on Earth millions of years ago. And drifting on its surface is the mysterious red spot, an immense cyclonic storm that has raged for hundreds of years and continues unabated. Radiating more energy than it receives from the Sun, and circled by 14 moons, Jupiter is like a miniature solar system. The next largest of the gas planets is Saturn. girded by rings which, as we approach them, resolve into countless particles of frozen debris and ice, each a tiny moon orbiting the massive planet. And as we continue past the frozen worlds of Uranus and Neptune, we arrive at the outermost planet in the solar system, Pluto. It moves in a dim twilight of unimaginable cold. The sun, 4 billion miles away, is only a brilliant light in the night sky. To travel beyond the solar system to the nearest star would require a journey of more than 5 trillion miles. Yet our sun is only one of 100 billion stars, widely separated from one another in time and space, but all bound by gravity, and all revolving around the central core of our galaxy, the Milky Way. Drifting between the stars are vast clouds of gas and dust, the nebulae, made luminous by the radiation of stars within or near them, or darkly obscuring the light of whatever lies behind them. Here, new stars are being born. About a half-century ago, our galaxy was thought to be alone in the universe. We now know it to be one of a local group of about 20 galaxies. And strewn through the vast reaches of space are more than 10 billion galaxies, grouped in clusters as far as our most sensitive instruments can reach. Little is known about the evolution of galaxies, and why some are formless or irregular, others elliptical, and still others spiral-shaped. And we know as little about the galactic core and its role in the galaxy's evolution and structure. The problem has become more perplexing by the discovery that some galaxies are in a state of extreme disarray, exploding, ejecting gaseous matter, or interacting with other galaxies. Even more puzzling are quasars, star-like objects, emitting as much energy every second as the sun radiates in some 10 million years. They appear to be among the most remote objects in space. Stars are born without their lifespans and die. The life history of a star is marked by an opposition of two kinds of pressure. One is the pressure created by the energy in the core of the star, pushing the surface outward. The other is the crushing force of gravity pulling the star's surface inward. When these are balanced, a star becomes stable and shines steadily. As hydrogen fuel is depleted, the release of energy is insufficient to withstand the gravitational pressure, and the core collapses. But compression by gravity raises the temperature in the core, and helium ash rekindles the nuclear fires. Vast amounts of energy are released and lift the outer zones against the force of gravity. The star is now a red giant. In the final stage of its evolution, it is the mass of a star that determines its fate. The Sun, a medium-sized star, remains stable for approximately 10 billion years. Then it will expand to 400 times its present diameter. As it expands, it will engulf the inner planets, Mercury, Venus, Earth, and Mars, and create a nebula extending past the outer planets. After millions of years, its reserves of nuclear fuel will be exhausted, its outer layers will have dissipated, and only a white dwarf star remains, no larger than the Earth.